All right, Praveen. In the last video, you defined voltage and current for us, two important electrical parameters. Now, since both of these definitions intimately involve either the separation of electrical charge or the movement of electrical charge, I want to discuss very briefly some of the fundamental properties of electrical charge.
Yes.
So this is now on the properties of electric charge. Now, one of the reasons why I emphasize the word electric is that there are many different types of charges in physics. We know that electric charge itself mediates what we call the electromagnetic force. However, there are other forces in nature, things like the strong nuclear force. We know that atoms are made out of protons, neutrons, and electrons. The protons and neutrons are stuck together in the nucleus. However, they should be repelling each other because like charges repel. So what is it that keeps the nucleus bound together and keeps it from exploding? Well, it's the strong nuclear force. Now, the strong nuclear force, it has been discovered through many experiments that there are, as opposed to the electric charge, where there are only two fundamental types of charge, the strong nuclear force, there are 6 different types of charge, which have been named blue, green, red, anti-blue, anti-green, and anti-red. Right, so here for the properties of electric charge, the first one is that there are 2 types of charge. Right, so there are 2 types of electric charge. One which we call positive, and the other which we call negative. Now, these names are not arbitrarily chosen. The reason we call them positive and negative is to remind us that when you add a positive and negative together, they tend to cancel each other out.
Annihilate.
Exactly. Now, if you happen to have a chunk of positive charge in space, you're going to feel the electric fields everywhere in space. And if I bring an equal number of negative charges into the same space, it's as if there were no charge there at all. That's, again, one of the reasons why we call them positive and negative charges, because it reminds us of this canceling effect or additive effects. Now, the second property of electric charge that's extremely important is charge itself is not a continuous variable. It's not a continuous quantity. It is what we call quantized. There are discrete lumps or chunks that serve as the fundamental units of charge. Now, for negative charges, the fundamental unit of charge is the charge of an electron, and the fundamental unit of charge for positive charge is that of a proton. So here, charge is what we call quantized. Whoops. And in SI units, which you had talked about in a previous video, for the fundamental unit of positive charge, that of the proton, it is 1.602 times 10 to the negative 19 coulombs. And for the negative charge, it is that of the electron, it is negative 1.602 times 10 to the negative 19 coulombs. Now, one last thing that I want to mention is notice that the units of charge here are extremely tiny. They're very, 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 very small. 10 to the negative 19 is an absurdly small number.
Yes.
Now, the number of charges that we have within the circuits that we will be working with are so astronomically huge
In comparison
that
to this.
for all intents and purposes, we can consider the charge to be a continuous quantity. We can get any fraction of charge that we want. Thank you for paying attention, and we will see you for the next video. Thank you,
Thank
Praveen.
you.